Alright, so greetings to my respected COA lecturer, Dr. Aida. And now I'm Daniel Chung, and I will be responsible in presenting question 1. So based on these instructions in this table, we will have to carry out the operation on all of these values such as AND, OR, and XOR. First, we will have to look at the first question. We will move the 011000001B into AL, and also we are at the second operator, which is 0001101B. We have to AND both of these operators. Hence, after carry out the AND operation, we will have the result of 000000001 binary. We have to convert both of these value into hexadecimal form. Hence, at first, the value of AL is 61. After AND with this value, it will become 01 hexadecimal. Next, we will move to the second question. At this second question, we can see that both of these are in hexadecimal form. To carry out AND operation, it is advisable that that we convert both of these hexadecimal into decimal form. So for binary form, this 12H is 00010010, and for 3BH in binary form is 001111011. After we carry out the operation, the result will be 00010010. After that, we will convert. As we can see, the value of hexadecimal in AL register is still remain the same, which is 12. Next, we will move to question 3. The third question in this question 1. So we will have to move this 00001111 binary into AL, and we have to OR with this hexadecimal form. And as the same in question 2, we also need to convert this into binary form. So the 72H in binary form will be 01110010. Hence, we will carry out the OR operation. So for OR operation, if both of the values are low, hence it will be low. And if one of the values are high, hence the output will be high. Next, we will have to carry out the operation, and at last we will have the result of 0F and 7F. Lastly, the fourth question, we will have to move 83 hexadecimal into AL, and we have to add OR with this 26 hexadecimal. After we carry out the operation, the result will be 83 and also A5. As both of these, we will also have to convert into binary form, which is 1000011 and 001001110. And carry out of this operation, the result will be 101001101, and we convert it into hexadecimal, will become A5. So that's all for me about the presentation for question 1. Thank you.
Salam and good day, Doctor. I am Keng Keat. In this video, I will be presenting Lab 5 question 2, which will ask us to write instruction in assembly language code. The first question is jumps to label L1 if either bit 4, 5 or 6 is set in the BL register. Our answer for this question is test BL 01110000B, which will perform a non-destructive AND operation between BL and 01110000B. And the next line of the code is JNZ L1, which means bit 0 and bit 1 are set, so it will jump to label L1. The second question is jumps to label L1 if bits 4, 5 and 6 are all set in the BL register. And our answer for this question is NBL 01110000B, which means performs Boolean AND operation between BL and 01110000B. And then the next line is CMP BL 01110000b, which will compare BL with this value. And then the next line is JEL1, which means if BL is equal to 1, then it will jump to level L1. The third question is jumps to level L2 if AL has even parity. And the code for this question is OR AL, which will perform Boolean OR operation between AL and AL. And then the next line is JPL2. And this means if AL has even parity, and then it will jump to level L2. The fourth question is jumps to level L3 if EAX is negative. And the code for this question is CMP EAX 0, which will compare EAX with 0. And then we put the JL L3. This means if EAX is less than 0, then it will jump to level L3. The last question is jumps to level L4 is the expression EBX minus ECX is greater than 0. And then the answer for this question is SUB EBX ECX. This means we will minus EBX by ECX. And then we put CMP EBX 0, which will compare EBX with 0. And then lastly, the final code is JGL4, which means if EBX is greater than 0, then it will jump to level L4. That's all for me. Thank you.
Alright, so greetings to my respected lecturer, Dr. Aida. So my name is Chung, and I'm here again to present question 3. So in this question, we will have to analyze the following code segment, and we will have to interpret what does it really mean and what kind of conditional jump that we've taken in this question. So we will look at part A. If EAX is equal to 25, what kind of conditional jump will be taken, and what is the final value of EBX? So as we can see, now the EAX is equivalent to 25. And now here, we will have to compare 20 with the EAX, which is equivalent to 25. Hence, we can see 25 is greater than 20. Hence, the conditional jump that will apply is JG, which is jump if greater, as the value 25 is mathematically greater than the value of 20. Hence, it will jump to L1 instead of L2. It will jump to L1 instead of L2. The final value for L1 will be 0.00000001 hexadecimal, as we will move the value 1 into the EBX. Hence, this will be the final value for EBX. And now we move to part B. Why is the JMP out instruction is needed for this code segment? So it is really important that we include JMP out in this code segment, is because that the program will operate and initiate all the instructions in this code segment, even though those conditions are false, if the JMP out is not included. Hence, JMP out is really needed so that the program will not continuously looping and also initiate the instructions even those conditions are false. So that's all from me. Thank you and have a nice day.
Hi, my name is Jiau Ting A21EC135. Now I want to explain about the question 4 in the left 5. This is the question, the question 4. The question 4, this will copy in the code, Visual Studio Code, and this is the answer for the question 4. In the question 4, we need to define the three functions have the same purpose. Is we need to sum of the from 1 to n. Okay, now we need to see to the first function. In the first function, we need to initialize the 0 into the EAX and 1 into the EBX. EAX is act as the sum and the EBX is the value to be added into the EAX. Okay, in the loop, and for the this is the loop for the function 1, L1, and for this function interact, it will add the EBS with the EAX and increase the EBS by 1, and this L1 will loop until the ECS is equal to 0. If not, it will loop the L1 again the whole path. And that's all for the function 1. We next to the function 2. In the function 2 is also same. We need to initialize the values, and this is the loop for the function 2. And in the loop 1, it will add with the EBS with the EX and increase the EBS by 1 and decrease the ECS by 1. The ECS is the counter of the loop, so we need to compare the ECS to the 0. If the ECS is equal to 0, it will terminate, and if not, it will jump into the L1 and loop the whole part again, and that's all for the function 2. And we move next to the last function, and the last function decrease and ZECX jump. This is means that the component will jump if the ECX is equal to 0. So the same we need to initialize, and this is the loop for the function 3. And in the L1, we need to add the EBS with the EAX and increase the EBX by 1 and decrease the ECX by 1. And if the ECX is equal to 0, it will jump into the L2 and exit. If not, it will jump to the L1 and loop the L1 again, the whole part of L1 again. Okay, that is all for the function 3. And next we go to the debugging. We enter the tool, it will get the 3. Okay, this is correct. And we try another. $100. Okay, this output is correct. And try again. $1,000. Okay, that's correct. That's all for the question 4. And okay, now I will give the reflection for this lab. In this lab, I learned more about the assembly language. First is the loop, and I learned more how to wisely use the loop in the function. In the function, I first time to use the compare the values, and it can find the true or false. If true, will jump or next jump into the next loop or exit the loop like this. So this interesting. And the second is I have learned about the call function, and the 3 function we write is the small function will call in the main function like this. call some pro using loop and using decrease, and decrease there is the exact like jump like this. So I learned more about this in the question 4. So that's all for me. Thank you.